Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's Data Science and
Woo!
Business Intelligence subgroup. So today we have somebody I've vetted Eugene for the past, what is it, like 6 years or
It,
so.
it it depends on which part. I mean, you started to go deep with the vetting with the podcast, right?
Right.
So I do feel like I'm evaluated every single time on whether I'm accurate. So
We'll
yeah,
see about that.
yeah.
But Eugene is going to give us an advanced introduction to DAX. So please take it away.
Will do. So let's share. All right. So it's funny. A friend of mine was like, it'd probably be better to title it an introduction to advanced DAX. And I should just change the title entirely, but this is intended as an advanced introduction, which is an oxymoron like jumbo shrimp and all that kind of stuff. But where it came from was originally I just had an introduction to DAX. And then I realized that what people, at least in my opinion and in my experience, really need is they don't need like a level 100 session on DAX. They need like this sampling platter of all the different levels so that they know what are the hazards. Well, I'm mixing metaphors. Hopefully your sampling platter doesn't have hazards, maybe a choking hazard or something like that. But basically, where are the trouble spots when you try to get started with DAX? And so we'll talk more about that in a little bit. But my name is Eugene Meidinger. I'm an independent consultant as well as a Pluralsight author. And so my job's kind of weird because I have two different jobs. I get paid, X $100 an hour to consult on Power BI, and I would like to think that I do a good job because no one's asked for a refund as of yet. So that's the low bar that I've been able to hurdle so far. But you never know if people are like, "Oh, that was really crappy," but we're just going to move on, right? And that's a lot of hurry up and wait kind of work. I've had multiple times working with my friend Carlos, who is kind of the main consultant, doing Power BI work for his customers, and they'll say, "Hey, we need something in a month," and we'll be like, "Well, it is December, so we can do X in 3 weeks." And then we'll have the initial talks and we'll get started, and then there'll be a holdup, right? And then suddenly, what had to be done before Christmas now needs to be done in February, right? So there's a lot of hurry up and wait, and so you get a little bit of whiplash with the authoring piece because the authoring piece is this slow burn. It is like the crock pot of crock pot. I can't use words today, so please forgive me. But it's like a slow cooker for work because what happens with Pluralsight is you're handed a scope of work for a course, and they've been more structured about it. So usually there's some opportunities and you pick them. So right now I'm doing a course on Jaspersoft. If you've never heard of Jaspersoft, that's because nobody's heard of Jaspersoft. Jaspersoft is basically SQL Server reporting services, and it's from a parallel universe where they wrote it in Java instead of C Sharp. I kid you not, like it's very, very similar. And I have to learn that technology in 2 to 3 months, and I have to spend about 100 to 150 hours producing 1 to 2 hours of content. And it's very lonely work, and it's very slow, methodical work, and a lot of like staring out windows thoughtfully. So it's a challenge to mix the two, and I'm more than happy to talk about any of those afterwards. I'm also a co-organizer for the GroupBy conference. Blythe Morrow and her marketing company Paper Sword manages that, and I'm a volunteer and I help a lot with the speaker mentoring side. So enough about me. Let's talk about DAX. And we're going to take a note from my film theory class in college and focus on something called structuralism, where you define something by what it isn't. And DAX is not Excel. It looks like Excel. It has similar functions. It's not Excel. DAX is not SQL. You can use it in some degree to query data. You can use it in some degree to model data, but it is not SQL. DAX is not MDX. MDX, I want to say, stands for multidimensional expressions. One of the
You are
like,
correct.
thank you, yes. um, so I knew one of the like 5 people who still know how to code MDX would verify that. It's not any of these things, right? And if you don't internalize this, Dax is very painful, because whenever I started learning Dax, I thought, well, I know Excel, I know SQL, it's going to be some Frankenstein baby of the two. And it was not. It looks a lot like Excel, but it is a columnar database at its core. And in order to work with it, you have to learn to think in columns. And we'll talk about that, but it meant a lot of unlearning of things, because you have to learn to think in columns and full tables and filters, lots and lots of filters and filter manipulation. And so at its core, Dax has different verbs. It has different nouns than what you might be used to. And so the concepts, the mental model, those nouns and verbs are much, much more difficult and important than how you form the sentences of Dax, right? Than the syntax. So almost to say the grammar of Dax is more important than the syntax, right? Forming sentences, forming formulas is really easy, and you can have some powerful code in Dax that's actually very, very clean, very small, very concise. So let's start talking about what Dax is. And Dax is good at 2 things. And this slide is so important that I'm going to have it 3 times in this presentation. And it reminds me, if at any point you have any questions that are relevant to what we're talking about, please feel free to poke Kevin, who will loudly interrupt me and I'll be startled, and then I will answer the question. So Dax is good at 2 things. One is aggregations. You have done aggregations. I am confident that everyone in attendance here has done an aggregation before. All an aggregation is you take a column of data and you summarize it. You just, if you've done a sum, if you've done a group by, if you've done an average, you've done an aggregation. The other thing that Dax is good at is filtering. So you can imagine a situation where you're looking at a sales report and you want to narrow it down to a specific salesperson, a specific region, all that kind of stuff, right? And so, hold on, the thought has disappeared and it's back. So the thing that I want you to understand is, if you're not doing those 2 things, if you're making invoices in SQL Server reporting services or Crystal Reports, don't use Dax. 100% do not use Dax, because you can cook a piece of toast with a butane torch, but it's going to be a bad time. Dax is a butane torch for aggregations and filtering. It is not a general purpose tool. So I talked at the beginning of, hey, Dax it's hard to learn. There's all these hazards. And so what does that look like? In practice, what is the shape of the learning curve? And so again, everything that I talk about here is based on trying to learn Dax in 2016, right? When Power BI had only been out for a year. And there were a number of books on SQL Server analysis services, but I was arrogant and I thought, you know what, I'm just going to Google everything. Because you can Google your way through T-SQL, 100%. You can Google your way through Excel formulas. It is very difficult to Google your way through Dax. It's a lot better now. There's dozens of folks writing amazing blog posts. But what you run into is you get some really goofy names, and we'll talk about some of those function names that just make no sense whatsoever. So you start out with scalar functions. And a scalar function is just a fancy mathematical term for a single value, right? And that's compared to, say, like vectors. So you think about graphing. You know, I'm sure many of you took algebra, whether you liked it or not, in, say, middle school. And you had to graph points on a chart, on a piece of graph paper or what have you. And those points, those coordinates, had multiple numbers. They were a vector in some degree, depending on how you looked at it. And you might extend that vector out by multiplying it by a scalar. It would scale it out. A scalar function is something like a trim or concatenate or a plus, and it returns a single value instead of, say, a table or a list. Scalar functions in DAX work exactly like you're used to. If you worked with Excel, easy peasy. Calculated columns work exactly the way that you expect them to. If you've ever taken a table in Excel and then added a new column, put in a formula, and dragged it down, you've created the functional equivalent of a calculated column. You have horizontally expanded the table by adding another column, and you have saved the results to your data, to your database, which in this case is Excel. And this is all fine and dandy, and you start feeling like, okay, I get this. And then you bang your head against the wall because the curve shoots up, because you start learning about measures. And measures are one of the other ways to implement business logic. And they function completely differently from calculated columns, right? Calculated columns are intuitive, measures are not. And then you start learning about the stuff you can do with filtering. And then you start learning about evaluation context. And then finally, it starts to click. And you start learning about time intelligence and nesting evaluation context and all this stuff. And so what I want to talk about, why I call it an advanced introduction, is we're going to talk about this. We're going to talk about the part of the learning curve where it shoots up and suddenly becomes difficult. And so my goal is not that you're going to walk away from here being any kind of expert at DAX. My goal is that you're going to know what stuff you need to Google come tomorrow whenever you start working with DAX or whenever. So we're going to cover this part so that you have a lay of the land. You have an idea of what's out there. So what are we actually going to talk about? So like I said, we're going to focus on these concepts. And we're going to start with calculated columns versus measures. How do I implement my business logic within my model? Then we're going to talk a little bit about columnar storage and how that impacts not only the way that you interact and query the data, but also the way that it's stored and compressed. We'll talk about aggregations, and you guessed it, filtering. Finally, we'll talk about filter contexts. These are things that manipulate what can be seen by the expression. And we'll talk about iterators, which are like cursors in SQL. They break the columnar paradigm and go row by row by row. So when you're dealing with DAX, there are in fact two types of business logic. The first one is calculated columns, and the second one is measures. Now, what do I mean by business logic, right? Well, I used to work at a place that was a very peculiar business. My last job was at a fire protection company that owned an IT company. And it was a family-owned business, so it kind of made sense at the time because they were getting poor quality IT service from this company, and they said, well, we'll just buy them and make them better. And at a certain point, the owner decided that they were going to migrate from 5 or 6 pieces of software, including Dynamics Great Plains, to a single ERP solution that was targeted at fire protection companies. And in theory, this was a really good idea because it was going to reduce work. It was going to be something that was focused on the industry that the fire protection side was invested in. It made a lot of sense. The problem is the software was written by another fire protection company. It was not written by a software vendor. It was written in VB6, not VB.NET, VB6, Classic ASP, and MySQL and Adobe Flex. So technology is not like wine. There's not vintage technology, right? And the reason I bring all this up is that I had assumed that these were two companies in the same industry, and so the way they handled things was going to be the same, but it was not. The way that they scheduled technicians was different. One of them did it a week at a time, and one of them did it a month at a time. The way they handled invoices was different. The way they handled receiving was different. And what you find is despite large businesses often following what's called generally accepted accounting principles, they're generally accepted. They're generally followed, and there's always edge cases. You go and you ask and say, well, how do I do this report on gross sales? And they say, oh, well, it's just quantity times price. And you're like, oh, that's easy. And it's like, well, unless there's a discount. It's like, okay, that's fine. It's like, well, unless, you know, the wind is blowing 15 miles per hour to the west, and then we get a discount because of this, and just it all blows up. So business logic is how we take the peculiar shape of each and every business and the data environment that business is situated in, and we take all those exceptions and we bundle up into something that's just gross sales, that's profit margin, whatever. So how do we implement this with calculated columns? What are calculated columns? So a calculated column represents a single numerical value for a given row, and it is computed at time of creation and refresh. So what that means is it is pre-computed. It is materialized. So if you use SQL Server, then you may have played around with persisted computed columns. If you have worked with Excel, then it's just like I said, it's like if you were to create a bunch of formulas and then copy and paste the values or something along those lines, right? It's pre-computed, it takes up space. It is materialized and stored. It will make your Power BI files bigger. And it is attached to a specific table. And so what that means is once it is computed and then compressed, because to my understanding it is compressed last, at that point it is functionally identical to any other column in the table. And it is associated with a specific table. And so normally a calculated column can only see the row that it exists in. What that means is if you refer to a column in a different table, it's not going to work the way that you expect. There are ways to get around this, but what's important is when you refer to a column in the same table, what you're actually referring to is that individual cell within a row because of something called a row context, which we're going to touch upon briefly. But the way that I think of it is a row context is like horse blinders that narrows you in to just the row that you're in. Okay? And so we'll talk about that more later. And one of the other things is you can use calculated columns as for filtering, and you can drag them over the results area. You can't filter based on a measure. You can do stuff like top N in Power BI. So there sort of is a way, but again, what's important is that a calculated column is concrete, it exists. So here we have unit margin as sales price minus cost. I have it in the picture as gross margin, so I need to change that. But you can look at this code and it's going to work exactly the way that you would intuit it. Okay, and that's really convenient. But my recommendation is do not use calculated columns unless you have a clear need for it. You should always try to start out with measures because in the long term, you're going to have a cleaner data model and you're going to run into less confusion. So how do measures work? Well, a measure represents a single value per data model per point in time, per like where you are now. You know, I think about the Spaceballs movie where they're like, well, when will then be now? And the answer is soon, right? A measure represents a single value for all of the data model for what you're looking at this moment. And so it is computed at runtime. It is computed dynamically. And that dynamic result is based on the filters. It is based on something called a filter context. And so we will also talk more about that. But row contexts are like those horse blinders that only let you see a single row. A filter context is much more like those old 3D glasses for the movie theaters, not the polarized ones, but the ones with the different colored gel film of like blue and red. And based on the filter, you see different things, right? So that's what a filter context is. And when we talk about evaluation context, we're either talking about a filter context or a row context. Those are your two options. And I want to reiterate, I do not expect you to walk out of wherever you're at and go, all right, I understand row context. What I expect you to get is, okay, I need to learn about filter and row context, okay? A measure is not attached to any table. It is associated with a table from a UI perspective. It will look like a column, but it does not care where it is associated. It is aloof. It may be at the party, but it is doing its own thing. And so it sees all the data at once. You can refer to a column in this table and a column in that table and a column in that table, and it just works, usually. So here's an example of a measure, and I love using pictures from Excel because in Excel, they show you the measure. In Power BI, when you're looking at the data, they don't have, at least from what I've seen, they don't have a little measures bar below. But here we can see that total quantity is associated with my sales table, but it's not a column, and it's not multiple values. It is a value. Right now, that value is 17. At a different point in time with a different filter context, it might be a different value. And then the last thing about columns versus measures is there are things called implicit measures. And you can go in Excel and look at these, and I think you can do it now in Power BI. It's been a while since I've had to do it, but if you drag quantity into a values well, it will implicitly create that code you see there on the bottom right, sum of quantity. And you want to try to avoid implicit measures where possible because you want to have complete control over the logic you're creating. Now, generally, it's simple enough that it's not an issue, but I have run into the issue with Excel where I created the same implicit measure multiple times, and I changed the formatting on one spot, and it changed it everywhere else, right? And that may not be what you want, right? It may or may not. So you want to try to avoid implicit measures because you want to have as much control over the formatting and other details as possible. But inherently, they're not harmful. So we are back at the most important slide that you're going to see one more time. Dax is good at two things. It is good at aggregations and it's good at filtering. So let's talk about aggregations. What is an aggregation? An aggregation is combining a group of values into a single value. You have done aggregations before. If you've done a sum, an average, a min-max, you've done aggregations before. You're taking a column of data and you're going to smush it into a single value. Simple, right? So why is this important to talk about? Well, Dax stores data as columns, and this is incredibly efficient for simple aggregations. This is efficient for single column aggregations. And so many aggregate functions will take in columns as parameters. And one of the things that becomes very quickly confusing is that we use the same syntax to refer to a column as a whole, as an entire entity, as we do to refer to a cell within a column when we're doing something like a calculated column formula. Okay, so whenever you have a row context, the syntax you use to refer to that cell in a column is the same because you're just calling it by the name as when without. So that may have sounded like word soup, but the important thing I want you to get is that Dax is optimized for columnar operations and especially for single column operations. So columns are the fundamental unit of measure. And so anything where you're aggregating a single column and then using a couple of filters that are just simple, this value is this kind of filters, or this value is one of these options, lightning fast, super, super fast. And part of that is how we store the data. So I have a table here of color, state, quantity. And so you can imagine maybe I'm selling like, I don't know, fancy enamel pins. And we can see that red is the most popular color, but I want to do an analysis on, okay, what's the quantity by color? How much of these red pins are we selling? And SQL Server is a row store database. It stores the data as rows. Now, imagine that this table is 50 columns wide. If you've ever worked with anything with the name Dynamics after it, then you know what I'm talking about. And because SQL Server stores the data as rows, then in order to get these two values, blue and 1, I have to grab the entire row. Depending on the size of your table, I might have to read, say, 2 or 4 kilobytes, or even an entire 8 kilobyte page to get what is likely to be a few bytes of data. And in a row store database, if I want to scan through just color and quantity, I have to go row by row by row. This is a slow and tedious process. If you work with SQL Server, you've probably heard of something called RBAR, which is not a rebar, which is not a direct reference to the metal bars they put in concrete, but is in fact an acronym for row by agonizing row. Well, what if we split this up? What if instead we stored the data as columns? Well, in that case, we could go column by column, and now we've got the data we need. We're done, right? In addition to that, the data is compressed. There are 3 types of compression and encoding that occur when you're dealing with the DAX engine. The first is value encoding, which is fairly rare and unimportant for the most part. The way that I describe it is, I am a type 1 diabetic. Oh, wrong one. I am a cyborg. I don't know how well you can see that, but I have a continuous glucose meter, and I have to get blood work every 3 months to see if I've been good or if I've been eating dessert, and then my endocrinologist can yell at me or whatnot. And I get a bill for the blood work. I get a bill for seeing the doctor. And I get my blood work from Heritage Valley. And what's weird is that I will have an account number. And the account number will easily be 8 or 10 digits long. I think depending on who I see, it can be like 12 or 16. I forget exactly. But imagine my account number is like 5,237,314. I live in the greater Pittsburgh area, which to my recollection has about 2.1, 2.3 million people in the greater Pittsburgh area. I can promise you that a small hospital in Beaver County does not have 5 million customers. So what's going on? Well, what happened is some smart IT person said, you know what, we're going to put the department number at the beginning of the account number, which makes it really easy to figure out what system the bill needs to go to when it's paid, but gives really weird long numbers as a result. Now, imagine we had those numbers in the database. Well, value encoding says, you know what, I see this 5,237,000 part being repeated a lot. I see that the values are in a narrow band of actual numbers. So I'm going to keep the delta. I'm going to keep what's different, and I'm going to store that 5 million somewhere else and then recombine it when I need it. So that's value encoding, is basically saying we're just going to store the range of values and we're going to subtract out that base. Dictionary encoding is pretty simple. If you've ever used a hash map or a dictionary object or something like that, you understand how this works. But if you haven't, in Pennsylvania, we have the world's most famous groundhog, and his name is Punxsutawney Phil. Punxsutawney Phil is a very long name. And so you can imagine if we had a bunch of information about different groundhogs and we had Punxsutawney Phil, his name kept showing up, you might say, well, I don't want to spend 20 characters, 20 bytes to store that name. Why don't I store it in, say, a lookup table or a reference table or some kind of dictionary object, and just store the number 1 for Punxsutawney Phil. And then later, if I need that value, I'll go look it up. And so that's what happens. Nearly everything in DAX is put into a dictionary object. What this means is that you can get some really great compression unless you're working with a unique column. And then you'll have a bigger column, right? Because you're trying to create a dictionary entry for something that only occurs once. So that's dictionary encoding, is repeated values are replaced with integers that represent those values. And so for filtering and compression, super efficient, but for large text values, unique keys, all that kind of stuff, not so much. And then finally, we have run length encoding. And this is dependent on the sorting of the data, something that you largely don't have control over when it comes to DAX. Although if you're using SQL Server Analysis Services, I believe you can kind of hint at the way you want it to be sorted. And you can also hint at the way that you present the data to DAX. But you don't, in Power BI, you have no strong control over this. So imagine we have our list of colors. And again, we have red that shows up 4 times. Well, do we really want to store red, 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 red? Instead, what we can do is we can have blue, comma 1, green, comma 2, red, comma 4. We can store the length of a run of repeated values, right? That's all that is. And you can imagine that the more columns you have, the more fragmented your runs become, because it sorts one column and then another and another, and by the time it's done, it's pretty much completely disjointed, right? So you not only want to avoid columns that have unique values, but you also want to avoid having more columns than you need, because again, it impacts compression. So that's aggregations. Let's talk about filtering. Filtering in DAX is extremely powerful. You can do things like undoing a filter that there's no good way to do that in SQL. You can have really concise date logic, like year-over-year date manipulation, with the filtering capabilities in DAX. And there's 2 types of filtering when it comes to DAX. There's what I would call implicit filtering and explicit filtering. I've heard different names for this. I've heard user filtering versus query filtering, but to me, this phrasing helps it sink in. So in this case, implicit filtering is something that's implied by the report design or the choices made by the user. So if you have a slicer in Excel or a slicer visualization, or using the filter pane in Power BI, then this is a filter. And it sounds obvious, but what's important is that we can make changes to this in code. It can also be implied by something like cell location in a pivot table, or by bars in a bar chart. And so what's important here is to understand that here we have a pivot table and we've grouped everything, we've organized things by color. And the result, the calculation, is functionally equivalent as if we had said manually, hey, color is green. And we can do things to detect this and manipulate and undo it if we want to. Explicit filtering is filtering done in code. And explicit filtering supersedes implicit filtering. And so here we can see what may seem like a weird bit of logic. And I'll explain actual use cases in a second. But imagine that my favorite color is green. My favorite color has been green, but I basically felt at the age of 5 I had to pick a favorite color, so I just picked green. I have not in the past 25 years, 23 years, reevaluated my favorite color, but let's say my favorite color is green. Well, what I could do is I could write a measure that says, you know what? I don't care what color the user has selected through the design of the report. I want to know what the total is for the color green. And so here we can see that we have our regular total quantity measure, and it goes 9, 8, 17, that's fine. And on the right, it's 999, right? And what's going on is there's something called a filter context. A filter context is a combination of all the user filters, right? And these can be filters that are associated on a column level, or they can be associated with an entire table, depending on the logic that's going on. And there's a function called calculate, which allows you to overwrite the filter context. It allows you to manipulate and change that filter context. And so one thing we might want to do is remove filters. So we can use the all function to remove filters. This is extremely useful when we're doing date manipulation, because a lot of times I want to know what the current date is, or what the date range is, right? So maybe I want to know that the data goes all the way up to, say, March 3rd of this year. And I want to store that information somewhere, March 3rd. And then I want to move the date filters to March 3rd of last year, right? And part of how you would do that might be with the all function. And so you can use all on a whole table or specific columns. And so here we can see a situation where we say, okay, I want to see all the colors. I want to ignore the color filters. And so over on the left, it works the way that we'd expect. But over on the right, we're not dealing with color, we're dealing with category. And so it doesn't modify the behavior. So we can be precise. Another situation where you might use all is a slice of pie analysis. You can imagine a situation where we take over on the left 9 and divide it by that 17 to get our percentage. What percentage of products sold were green? And the answer is going to be something like 54% or what have you, right? And so whenever you want to do a comparison analysis, maybe I want to benchmark against black products. If I want to do a slice of pie analysis and compare it to the entirety of sales, if I want to do date manipulation, these are all situations where being able to undo the filter, to manipulate the filter context becomes very important. And I have no idea how you would do this in SQL. I would think you'd have to do some type of parameterized function or something like that, because in T-SQL, you have a where clause, but you cannot have an unwhere clause or an anti-where clause, right? At least to my knowledge. And something that's important is that when you're applying complex filtering, it's not gonna work immediately. It's not gonna work right away. So here, we can imagine a situation where we wanna look at low margin products. I wanna know how many units were moved for products where our profit margin is less than $1. And if I try to write this code in DAX, I'm going to get that long error that doesn't even fit on the screen. I had to shrink it down. And so we can't do this. When you're working with Calculate, Microsoft has put a safety device on it so that you do not accidentally write slow performing code. What we need to get around that is something called an iterator. And so an iterator goes row by row. And you might say, well, that's going to be a lot slower. Why would I want that? And the reason is that whenever you have to take two separate columns and kind of zipper them back together, you want to use a special piece of code. And so in this case, we're going to use an iterator called filter. And filter's kind of weird. You look at the name and you think, okay, this just applies a filter, but it's more complicated than that. It actually returns a filtered table, which Calculate then uses to determine what to show or not show. This is one of those things where it's like you start working with DAX and you're like, this is weird, right? There's plenty of people, I've found plenty of forum posts where people expect filter to be more like an action, but instead it's more like a mathematical function. So here's an example with filter. What we could do is we could say, okay, I want the sum of quantity, and then I want to use this returned table based on the table of sales, but filtered based on the trueness of this expression of whenever the margin's low, right? And so now we're getting a total just for low margin products. And if it's not a low margin product, then it's going to return blank and it's not going to show up in our calculations. So finally, the other big thing is I want to talk about iterators in general. So iterators process the data row by agonizing row. And so they can be expensive to process. Now, my recommendation is starting out, don't pre-optimize, don't worry about it. If you are using an iterator and you are staying within the same table, you're probably going to be fine. The moment you need to start nesting iterators, which I've had to do before, or you start having to go across relationships to get data from other tables, then it starts to get expensive performance-wise. But using a basic iterator, generally speaking, isn't going to be too bad. an iterator filters the rows one at a time by creating a row context, those horse blinders, right? And it'll just move down like that little animation. Oftentimes, you might have a filter context. The user has applied some filters, maybe based on like category, and then you're applying a row context, right? And so these things can overlap. But anytime that you want to refer to multiple columns in the or fields in the same row, you're going to need that. So if I want to do sum of price minus cost, I can't do this. I can do sum of price minus sum of cost. That's fine. But I have to use an iterator called SumX if I want to do this multi-column logic. So let me give you another example. If I want to know the average profit margin, unit margin, I can, here I call it gross margin. Like I said, I need to update this. I could just take the average of a calculated column called gross margin. And that works the way that you expect. But if I don't have that calculated column, or if I don't want to clutter my data model, what I can do is I can take the average X of sales minus, or sorry, I can use average X, and I give it a table, sales, and I give it an expression. It'll go through each row, evaluate the expression, and then take the average of that. So a lot of times you'll find a regular aggregate function and then they add X. In my head, the X stands for like extreme Go-Gurt kind of stuff. I don't know what it actually stands for, but it indicates that there's an iterator. But remember, that's not always the case. We had filter and it wasn't called filter X. But here we can see our two measures producing the same exact results. And so anytime you have an iterator, you're going to need to provide a table to iterate through. And like I said, sometimes they can be expensive, but I wouldn't sweat it until you start seeing performance issues. Okay, so a couple other odds and ends. One is time intelligence. So time intelligence is what I like to think of as the the junk drawer of time and date functions. And so it's just a bunch of syntactic sugar, right? All it does is it takes in a date table and it manipulates filters on that table in an intelligent way. And so it's just what is often called syntactic sugar. You could write everything they've made for you by hand. It's just more convenient if instead of having to save the maximum date and then the minimum date in a range and then doing all that stuff, you just did dates year to date. So time intelligence is just a large variety of date and time manipulation functions. That's it. Another thing that I want to highlight are quick measures. So quick measures are a quick way to make DAX. They're not always the best or most performant, but they're great for learning and great for editing. So they generate valid real DAX. They're available in Power BI. And so you go on the little ribbon, you go to quick measures, and there's a bunch of templates. And you might say, I want minimum per category, and you tell it what you're taking the minimum of. You tell it what's your category, and it'll produce code like on the left. And so this is great for learning because then you can Google or Bing each and every one of these functions here and learn that way. So great for learning. Validate the performance of the code that's written, right? You may need to tweak it or tune it, but it's a great starting point. Two books I want to recommend. One is Powerpivot and Power BI by Rob Cauley and Avi Singh. It's an easy read. It's a little bit out of date now. I don't think they have a third edition. I don't think there's any intention of making a third edition. I haven't heard anything along those lines. Rob Cauley does have a podcast though, called the Raw Data Podcast that you may want to check out. But this is an easy read. This is one of the few technical books I can imagine reading on a beach. It's got a good sense of humor. It's made for Excel folks, by Excel folks. It's just, if you want a gentle introduction, this is a great place to start. I will warn you, the learning curve on this is deceptive. They will start out talking about like if statements and basic filters and all this stuff, and you're like, this is a piece of cake. And then suddenly you're talking about evaluation context and your brain melts out of your ear. So do be aware of that, but I found it to be an easy, enjoyable read. I believe this was written around 2016. So I bear that in mind, but still a great way to learn. The other book I recommend is The Definitive Guide to DAX. It is also in its second edition by Marco Russo and Alberto Ferrari. This is an amazing book. I need to edit that. I said good. It's an amazing book. It's extremely comprehensive, and it's in its second edition. If there was an exam on just DAX, this would be the study guide. Now, it is like 600 pages long. So, and it's a little bit dry. It's well written. It's for exam material, it's an enjoyable read. I'll put it that way, right? But do not expect a lot of engaging stories or anything like that. One other book, I don't have it on here. I'm going to make a note to add it actually. It's by the same folks. And it's called something like Data Modeling with Excel, Powerpivot, and Dax or Power BI. And it is a much smaller, much easier read, and it is largely a book about data modeling, but the language they use throughout is DAX, and so it can be a great way to learn DAX as well. All right. So that was a fairly quick presentation, but we've got plenty of time for questions if anyone has any. Otherwise, I am more than happy to let people get back to their evenings.
Yeah, we do have some questions here. And by the
Cool.
way, chat, if you want to add any questions, now's a perfect time to put them in here. So coming back from fairly early on, you had a few people who knew about Jaspersoft.
I apologize for any offense.
Oh, nobody said it was good. Don't worry.
Oh, good. Okay. Well, I have to make a course on it in the next month, so.
Ooh.
Yep.
Well, there you go. Eugene will have a course on it.
Yep.
Oh, let's see.
I was worried my hot takes are going to get me in trouble.
Oh, don't worry. I'll be the first one against the wall for hot takes.
I believe it. That's funny.
The Duke says, calculated columns in a different table I've found create memory issues and performance issues. Avoid if you have many of them because they seem to be costly, but that's just anecdote on my part.
Yeah, I mean, that sounds reasonable. There are ways that you can measure this stuff. And so I recommend taking a more empirical approach. I actually, let's see, Power BI Performance tuning.
Analyzer.
Well, there's that. But I have a blog post. I may need to add the Well, yeah, I have a blog post that is very, very detailed about ways you can try and measure some of this stuff or look into it. So I recommend that. But yeah, like you were saying, built into Power BI is the performance analyzer as well. So you can use the performance analyzer or DAX Studio to measure the speed of your code. You can also, I believe Marco Russo and Alberto Ferrari have a way to look at the size of your data model and see how much space that calculated column is actually taking up. So there's two ways to approach that. You can look at the speed and the size, for sure.
Makes sense.
Yep.
So you had talked about iterators, and that was a row-by-row processing. Can you do custom code development within iterators?
So, so I'm assuming we're talking about how, like in T-SQL, you can write, or SSAS, you can write C# code to run faster and be more performant. Is that?
Yep.
To my knowledge, no. I'm not familiar with any way to write custom code for DAX. Generally, in my experience, the way you get around performance issues is you do a couple things. One is you pick and choose your fights with what you want to pre-materialize. So that's one thing. Because again, if you can condense that logic to a calculated column, then doing some kind of aggregation on that is a lot more manageable. One of the other things is to take a close look at the distinction between the formula engine and the storage engine. So when you're working with DAX Studio, please feel free to email me at eugene@sqlgene.com if you need some follow-up on this. Actually, no, let me bring that blog post back up because I think so if you literally, I'm like number 3 if you Google like performance tuning for Power BI. But if we look for DAX Studio, here we go. Confirm that the storage engine is being used, right? And so basically, oh, that's a video, so I'm not going to go straight to that. But basically, what's going on is that the DAX engine has two engines inside of it, essentially. There is the formula engine, which is flexible but slow, and the storage engine, which is dumb but fast. And what you want to do is to see, am I taking advantage of the dumb but fast engine, which largely can only do simple scans and aggregations. And so I have literally seen 2 to 8x performance slowdowns from including if statements, from including conditionals nested in that kind of logic, right? Which is crazy, but I've seen it. And so the moment that it decides this is too complicated, I need to use the formula engine, you can run into real performance problems. So if you have an iterator and it's slow and you're trying to figure out what to do, what I recommend is step 0 is start measuring it. Step 1 is to figure out, okay, what can I materialize so that I don't have to deal with this. Step 2 is to simplify the logic as much as possible and to make sure that you're using the formula or the storage engine versus the formula engine. There's other things you can do, but yeah, to my knowledge, there is absolutely no way to write custom code that you can run in DAX. On the Power Query side, you can run Python and R code, but the way that they do that is full of shenanigans, like writing the data to CSV files on the back end, so it may not be faster. But yeah, on DAX, you just have to be smart about this stuff. Good question. I appreciate it.
Yeah, it makes a lot of sense. So let's see. Too bad Vertipack chooses Too bad Vertipack chooses the sort key for you. That's when you were talking about sorting sort keys.
So yeah, so Vertipack is kind of the internal name for the DAX engine, and yeah, from what I understand, you can hint at it with Power BI by the order that you pull the data in. So if you're using views or queries or something with a sort, you can in theory do that. But because it's going to be satisficing, right? It's going to find a good enough option. To my recollection with SSAS, there are configuration options you can specify or something along those lines. I'm fairly certain, but it's been a while since I've had to mess around with that. But yeah, it's a good point.
Yeah, and your example where you were showing green, your favorite color, or childhood use favorite color, intuitively you would think that it would show 0 for red when it's not green in the implicit context.
Yeah, so I can talk about that actually. Let's go back to that. So I agree with you. It is unintuitive, right? And so what is going on? Oh, come on. It's at the end. I should have started at the end and worked my way there. But now you all have to suffer by reviewing the talk here. Okay, so can I might be able to edit it. Let's see. Can I edit it while it's up? I think so. So here's what's actually going. Yeah, we're doing it live. And then I'll forget to like not save it. Oh no. Okay, that kind of worked. So you know what, let's just make it smaller and get it back over here, and then you'll deal. So here's what's going on. Okay. We'll go ahead and move that down there. And I'm gonna really hope I don't hit save. So when you write this code, what is actually happening behind the scenes that you wouldn't intuit pretty reasonably is it is actually doing this. If you overwrite a specific column in this way, what it is doing instead is it will apply all to color. So it'll say remove any filters on that column. And then it will use something like filter to reapply just on green. So that's what's going on, and that can be particularly confusing, right? So it is a kind of syntactical shortcut going on there, but it can cause problems. I'm pretty sure there's a way to do the logic that you would expect. I want to say, let me see. I want to say that it's keep all filters, but I could be wrong. Okay. Okay, so do not quote me on this because we're doing it live, but I believe that the keep filters function will allow you, it says overwrite the standard behavior, right? So we can see here that normally it replaces all existing filters. So I believe what you can do is you can use keep filters to get kind of an and response instead of a full replace kind of thing. I'd have to double check that, but that's my recollection. But again, it's a good comment.
Yep. Next, is filter a type of iterator?
Yes. I think I touched on that, but filter is 100% a type of iterator because it produces a row context. So the hint that you get is that it takes in a table and an expression, and it's returning something based off on that. So 90% of the iterators are going to follow that formula signature of table and an expression that it's going to evaluate on a row by row basis. Now there are exceptions, I believe, like add columns has a very different formula signature, but it is an iterator as well. But yes, filter is an iterator, and it's one of the most common ones you're going to use. And so that's part of why I say don't pre-optimize, because the filter function is, again, as long as you're staying within that table and you're not having to bust out of it to pull stuff from a different table, it's really fast. It's really performant. But great question.
Any comments about user-defined functions?
So I'm not familiar with any user-defined function capability within Dax directly. If there is, that's new to me, but again, it's been a heck of a year. That being said, I think it's pretty common and reasonable to, one, use the variable functionality, which is super great for making clean code, and also for nesting your measures, right? I think it is extremely reasonable to say, have a measure for sales, and then instead of redefining that logic for year-over-year sales, to basically nest it within that function. I find that to be smart reuse, and usually that works out pretty well. There's been a couple times where I've had something 3 layers deep, and it was more efficient to kind of hard code it, especially if I could do some kind of filtering or clean up the logic some. But I think I 100% recommend using the variable functionality, because that allows you to store values. And the nice thing about that is you can make sure that you're doing that at the outermost evaluation context. And so you don't have to do this mental gymnastics to remember what context level you're in. But it just makes the code cleaner. So I recommend using variables, and I recommend using intermediate measures, just being aware that you may either need to performance tune it later, or you may need to clean up your model if it's not a kind of measure you want a user to be able to drag and drop somewhere.
And the Duke also called out Vertipack Analyzer from the Italians.
Yes, let's go ahead and pull that up. I think that was the thing I was trying to mention about the size stuff. Yeah, I feel like that probably.
Yep, data model size.
Perfect. Yep.
And also, you got a nice comment here. I didn't learn anything this evening. Wait, hang on. There's a comma, not a period. Except how to discuss these concepts to the people I'm training in my organization. So thanks, Eugene.
Well, I mean, really, that just means I appropriately level set it as like a 100 thing, right? I didn't accidentally do like an intermediate session, right? No, that's funny. You had me there. Yeah. This stuff is hard to talk about, right? Because it's like you have to lay this brickwork to really be able to to have these conversations. Good.
Yeah, definitely. Also from the Duke, by the way, there was a time when Microsoft required you to call filter after calculate back in its early days.
Oh, geez. Well, I'll tell you what. I did not have to deal with DAX until I want to say 2015, and during that time I was writing extremely bad Powerpivot code, so it didn't even matter because I thought you had to use calculate for any aggregate, and I didn't know about the related function, so I was using the lookup value function instead of related. And I still maintain that code to this day, and I get paid handsome sums of money. So if you want to be a rich consultant, write bad code 5 years ago and then maintain it.
That sounds like a pro tip right there.
Yeah.
There are a lot of functions when it comes to DAX, which are also covered tonight. In your experience, which one has been the least useful function?
The least, well, I mean, so that's a difficult question because the truly least useful functions are like the statistical distribution functions that I've forgotten the name of. You know what I mean? But I would say one of the weirdest or most difficult ones that I haven't really used particularly often would be the earlier and earliest functions. In part because these are the epitome of bad naming when it comes to DAX. Because when I started using DAX, I was like, oh, I need to get the previous row. And I didn't realize it was like a columnar kind of thing. So I think, oh, I'll use earlier. Earlier does not get you the earlier row. Earlier is like the movie Inception, when they startle someone to bring them a layer up in the dream, like layer cake. Earlier brings you into the earlier filter context or row context or whatever you're dealing with. And it was one of those ones where I almost never used it. I hated when I had to use it. And the moment they added variables, I stopped using it because it was no longer less necessary because I could store a value in the highest context and then bring it down with me. So I would say in terms of least useful, there's a lot of stuff that's just it's niche. You know, I'm sure. Oh my God, this is like a blog post from years ago, but somebody like wrote code to generate linear regressions in DAX, and it's amazing and it's horrifying and all this kind of stuff, right? So if you're doing that, or you're doing statistical analysis in DAX, which I wouldn't recommend, then those kinds of functions are great. But yeah, earlier and earliest have like a special like loser's trophy in my heart because they're named poorly, they're hard to use, you're rarely going to use them, and the functionality for variables, which should have been in there from the beginning, just completely alleviated the need for them, honestly. So
makes a lot of sense.
Yep.
Comment here that DAX has no lambdas, but Excel recently got the lambda function. So
Excel has lambdas. Even the XKCD webcomic was joking about the lambdas, right? Sorry, I have to pull it up. Nope. Here we go. So let's see if we can. Basically, the joke is that when they need to do arbitrary computation, they just make a bunch of columns and have formulas going all the way down, which does feel appropriate. But yeah, I find it really funny that like Excel has lambdas, like they keep adding stuff to Excel, but yeah, to my knowledge, there's no similar functionality in DAX.
Yet.
Give it time.
So Raymond asks, is there a good deep dive book on DAX that you would recommend? And I'll posit outside of the Definitive Guide to DAX, 2nd edition.
Sure. That is a difficult question because I've heard good things about Mike Allington's book. But beyond that, there's not a lot that come to mind, right? Like if you go to like Pact Publishing or Apress, I'm sure you'll find some stuff, but there's nothing that super stands out. I will say that if you'd like to support me, my husband, and my dog, I have a course that's like this, but an extra half an hour that's on Pluralsight, and we'll get like $2. But no, in my experience, there's nothing that sticks out aside from the stuff that Marco Alberto Marco, I've combined them. Marco Russo and Alberto Ferrari have done. They do have video courses, which you may want to consider. From what I've seen, there's one on data modeling, which was free back when it came out. I don't know if that's changed, but they've got a bunch of them. They're very, very good quality. And so that and just getting your hands dirty, because I've found a lot of it is just wrestling with it, and you know, you just have to do that a little bit, and a lot of it starts to click.
Yeah, the other book that I could throw in, I don't know if you want to call it a deep dive, but Philip Seymour's Beginning DAX with Power BI, which is totally not a beginning book.
Yeah, it's funny because he works for Microsoft now.
Yep. But this was his pre-Microsoft when he was hanging out with Reza.
Yeah, Philip's funny because he was, to my recollection, he was one of those guys where like he would make like a video game inside of Power BI, and you'd be impressed and horrified at the same time. So he definitely knows his stuff. But yeah, I'll have to take a look at that as well, honestly. Cool.
All right, looks like we have any more questions from chat. This is your last opportunity.
Worth saying, if you have any questions about anything oddball, so Power BI in general, consulting, I don't know my favorite color, I'll be honest. I think it's blue, but anything else I'm happy to chat about. All right. Sounds like a resounding no. Well, I will let everyone get back to their evenings, and I appreciate getting a chance to present to y'all. I appreciate everyone's time.
Any Dax Pet Peeves? That's the last question we'll do for the
Dax Pet Peeves, yeah. So I already talked about the learning curve with Dax. I found that to be very, very frustrating. Honestly, what I would love to see is better syntax highlighting and functionality around like that whole inception thing. Like I would love it if, let's say, the curly braces changed color based on what level of nesting you're in, or you had some way like with Power Query to kind of see what the data looks like at the different steps, right? But instead, if you've got this complex logic, you just have to fudge your way through it. Or what I do a lot of times is make a bunch of intermediate measures and put them in the card visualizations and that kind of stuff. So my big thing with Dax is it's hard to learn, and it's hard to intuit whenever you're troubleshooting it. It's just a giant pain to figure out what went wrong. So that's my pet peeve for the evening.
Makes sense.
Cool.
So now that we've learned better debugging, better debugging would be nice. That
would be amazing. That's why DAX Studio is so great, because you can run arbitrary code against your Power BI data model, and so it's so much easier to stepwise your way through it and see the results.
All right, with that, we are going to wrap it up for this evening. So thank you so much, Eugene, for the advanced introduction to DAX.
The advanced introduction that I should probably rename. Yep.
I don't know. I liked the name. Although I was talking to someone who thought it was an introduction to advanced DAX. It's like it was not
probably
quite advanced.
The same. It's a mutual friend, so I suspect I know who.
Yes. Yep. It's Mala. We all know.
Hey,
Mala.
I didn't want to call her out, but okay.
So we are gonna meet again. Let's see. Shop Talk is 2 weeks from yesterday. And second Tuesday of the month, we'll have the Advanced DBA group coming back up again. So got a couple of weeks before we meet again. Meantime, everybody take care, and we'll see you again soon.